Hi there. I'm going to be using simple tools that you can make at home to make your own math games to help your elementary aged child practice their math skills in a fun way. So I'm going to be demonstrating some things that I like to do with students and that you can make at home. A lot of these games are just a piece of paper, some Sharpie marker, and I like to put them in a plastic sleeve so I can use them again and again, and so that I can draw on them with dry erase markers, or so they just don't get messed up. So I'm going to start with some younger games and then move to older games, and a lot of these games can be adapted easily for all different levels. So this example is my first one. It's just recognizing the number symbols and matching it to the number of dots. Rolling a dice, there's 4 dots, count them, 1, 2, 3, 4, and then you get to pop the number 4. And popping it could mean coloring it with a dry erase marker. It could mean putting a counter on it, such as a penny or a game piece, if you have some extra game pieces laying around. I like pennies. I got lots of them laying around. So some of my pennies, I painted one side to use them as different markers. So I have one side's green, one side's red, one side's yellow, one side's purple, so that I can use them for different games. And I have lots of them. They're easy and they're nice size and shape. So here's the number popping game. You can imagine you could also do something similar to this with maybe you roll 2 die and add or subtract them to pop a balloon, or have different math equations, and maybe it's 5 minus 2, and if you roll a 3 you get to pop that balloon. So that's ways that you could adapt this to be for slightly older children. This is kindergarten level, but you can adapt it, make multiplication problems, or roll 2 die and multiply or divide. So do a number popping game just like that for older children. Next, memory matching. This is again introducing kindergartners to number recognition. And this, I just used a deck of playing cards, put numbers 2 through 6 face down, and I like to use 2 red number 6s or something like that to try to make them as close to matching as possible. I like to use a whiteout marker and change my aces to be the number 1 instead, so that that's less confusing, and take all the queens and kings and jacks out when you're just introducing numbers and using playing cards. So I also go through and white out the small symbol in the corners when I'm introducing kindergartners to numbers, depending on the playing cards. These ones aren't too bad because it's so much smaller, but sometimes that can be confusing for some kids to have, there's not 7 there, there's 9. So to white out those tiny ones can be helpful. But using playing cards, and you put them face down on the spots, mix them all up, and working just recognizing numbers as a memory matching game. So again, for kindergarten, sort of, or preschool even, introducing numbers. My next one is a little bit more kindergarten, first grade age. This is called double cover up. And so this one, you can see it's numbers 2, 4, 6, 8, 10, and 12, which corresponds very nicely to the number cubes, the dice. So you roll a number, and then, 5 plus 5 is 10. So I get to cover up the number 10, or color it with my dry erase marker. And the first person to get all of their numbers covered up wins. And so you can see I have this board set up so that you can be sitting across from each other and both play on one board together like this. Slight variation. Instead of doubling the number, you can roll 2 die and cover up the number that they add to. So I'm going to take my 2 dice and roll them, and I got a 6 and a 3, so that's 9, and so I get to take my penny and cover up the number 9, or my dry erase marker and color the number 9. And so that's some simple addition. I'm practicing that. One of my favorite games, the very best and important one to play for all the time with many ages. I recently played it with a fourth grader who's at grade level, but just to remind them about quick mental math before doing some bigger, more complicated problems, I wanted them to be really solid on matching numbers that make 10. So the way I play this game is I again go through my deck of cards and take out the jacks and kings and queens, and I stick the whole deck of cards face up in the middle, and then see if I can do this. And then you go, okay, a 7 needs a 3. I don't have a 3, so I'm going to put it to the side. And these are probably not shuffled. But I keep putting cards to the side, and then it's the next person's turn, and they say, oh, a 7, that can go to the side. I need a 3. And then if I have a match, let's see. Oh, there's the 3. So now I get to take the 7 from the side and the 3 from the middle, and I get to keep those, and those go into my win pile. If I get a 10 up, I get to keep that one also, because it's about finding 10. So you're finding 2 cards that make 10 together, or a 10 up is just a freebie. And so this is practicing like that really quick recognition that 8 and 2 go together, 7 and 3 go together, 5 and 5 go together, 4 and 6 go together, so that it's automatic. And it's a game that can be played with kindergartners who are just starting to count. Let's see, I have 1, 2, 3, 4. So I need 1, 2, 3, 4, 5, 6 more to make 10. Or it can be played with older kids who need to just be very, very fast at making those recognitions. So if you're needing to brush up on that a little and remind them that this should be automatic, that you're spotting numbers that go together, which can be really helpful for later math skills, to remember to be on the lookout for those matches that make 10. Another game that is another dice game is my snail races. I love snail races because I love snails. This is out of the family math books, which there's a couple different versions of. I really like these. They have lots of games in there, and so I photocopied the snail race straight out of there, but you can also draw it yourself. It's not complicated, but they're really cute drawn there. The snails are numbered 1 through 12, and you roll 2 die, and you add them together, and I got, oh, that's my number 9. Let's have it. Oh, I got a 10. So I'm going to color in or put a marker on one spot of the 10, of snail number 10. And you can have kids decorate their snail and cheer for one of their snails. You're going to take turns rolling. You can do this in a group with any number of people. But you take turns rolling, and then whatever snail the die adds together to be gets to move one spot forward or add one more marker to their line. And when they reach or color in one more dot with the dry erase marker, and when they color in all their spots, these have 6 spots each, then they get to the garden, and your goal is for your snail to get to the garden. And with young children, they are betting on their favorite snail, they're cheering for their snail, they're taking turns, they're adding the dots on the dice together. With older kids, as old as, 3rd, 4th, 5th grade, and even in middle school, you can be talking about probability. So, which snail do you think is going to win? Not the number 1. There's no way to roll 2 dice and have it equal 1. That poor snail number 1 is just really hungry all the time. Snail number 12, you got to get double 6s. That's the only thing that makes a 12. So they're pretty hungry, not quite as hungry as that number 1 that just never goes anywhere. And so you could write down how many different ways. I keep having snail number like 6, 7, 8 win. Why is that? How many different ways can you make 7 with your 2 dice. How many different ways can you make 2 with your dice? And so that's taking your snail races to a little higher level and using the same game with different age. Another one that is adaptable, it's adding, starting with adding and adapting. And oh, I wanted to give credit to some of these other ones before I go on. So a lot of these ones, the Find 10 and the Cover Up and the Doubles Cover Up, and I think even the balloon popping game, all are coming from Constance Cammy's books. And she's amazing. I really enjoy reading her books. And she's got a whole series of them, one for each grade level, from preschool through, I don't know how old they go, but it's called Young Children Reinvent Arithmetic, Implications of Piaget's Theory. And so she's about kids discovering for themselves how math works and inventing math for themselves so that they understand it very deeply. And so she has a lot of these games and about the kids explaining what they did and why and how their thinking worked and finding lots of different ways to solve a problem, and incorporating play in creative ways into her math. So I highly recommend Constance Cammy's books, and I'll hold that up one more time so you can see her name there. These are called Young Children Reinvent Arithmetic, or Continue to Reinvent Arithmetic, depending on the book. Okay, anyway, so as we were going along, this is my original game that I call Mountain Climber, and I really love it. It's very simple, and you just draw your mountain, and you start at 1, 2, 3, 4, 5, 6 going up, and then 5, 4, 3, 2, 1 going down. And you can do this in the dry erase sleeve, or you can have kids just draw this on a piece of paper, or you can photocopy off a bunch of them depending on what you're doing. But I started doing this as a drawing activity. So we were doing it in a big group of kids, and when it wasn't your turn, you got to draw the adventure on the mountain, and you roll 2 dice and then see what you can do to use those numbers to make it equal this and then this and then this. So with young children, you're using addition and subtraction, and with older kids, you could use division, exponents, multiplication, whatever they can come up with. So if I have a 1 and a 4, well, I color in number 1. I can't think of any way to use a 1 and a 4 to equal 2. So I'll have to just be stuck at number 1. So I started down the trail, and then there was a river across the trail. And so I was stuck on number 1. And so you can draw your little person on number 1. Or you can move your marker or color it in if you're just going back and forth with 2 people and not having long turns waiting and having to draw dramatic things happening to your hiker. But if you rolled, say I rolled a 3 and a 2. Well, 3 minus 2 equals 1, so that's good. 2 is a 2, 3 is a 3. I can't equal 4, so I'm stuck. And the next time it comes around to my turn, I'm going to roll again and try to equal 4. And this time I rolled a 3 and a 1, so that equals 4, so I can color in the 4 on my next turn. No way to make 5 though, so I'll have to wait till my next turn and roll again. If I can't make a 5, I have to just wait and roll again on my next turn. And so I'm trying to make a math problem that equals each of these in order. So my first turn, I'm looking for, I can get as far as I can go with my set of numbers, and then I get stuck. And then I roll again and see if I can make this number until I get stuck and there's a number that I can't make. And then I have to wait for my next turn again. I hope that's clear. With older kids, you can go higher. Sometimes mountain climber becomes tower climber and they just go as high and high and high as they can and have more dice. So maybe you'd have 3 dice and you'd roll 3 dice. I got a 1, a 4, and a 6. So I've got, well, 1 is a 1, 6 minus 4 is 2, 4 minus 1 is 3. I got a 4. I got a 5 with 4 plus 1. I got a 6. I got a 6 plus 1 is 7. I've got, can I make 8? Let's see. And so this is getting into order of operations where you say, if I say, let's see, these are not good numbers for it, but I can, okay, so if I get 5 divided by 5, that's 1, and then 1 plus 4, that would be 5. Not that that would help me here, but for example, so you can say, okay, or I could say 4 times 5 is 20, plus 5 more is 25. So how many different ways can I add, subtract, multiply, and divide my numbers to try to reach a particular number? And with my mountain climber game, that goal target number that you're trying to creatively use your numbers to add, subtract, multiply, divide to get to keeps changing, because once you successfully make a 4, then you're trying to make a 5. Once you successfully make a 5, you're trying to make a 6. And with older kids, with middle schoolers, you can go up and up and up. You can throw in more dice. You could use larger number dice. You could do die 20 or die 8, die 10. Try different die in there and different numbers of die and see how that changes the game. So I think it's lots of fun. Similar is this game that is called Score with 4. And Score with 4 comes from this book series, which is called Problem Solving in Mathematics, Lane County Mathematics Project by Dale Seymour Publications. Okay, I'll hold that up for you. And there's a series of these: 4th grade, 5th grade, 6th grade, 7th grade, 8th grade, and algebra. And these are just books of games. They're like warm-ups and all different game boards, strange games that they come up with. I just found a bunch of game pieces I've been missing. So this game, Score with 4, has a bunch of numbers written on a grid there. It looks like 8 by 8 grid with different numbers, and you roll 3 dice, and then you try to use those 3 dice to make a math problem that equals one of these numbers, and then you use a marker for different colored markers for each of you. So here I have a white marker and a black marker. Not that you can see it, but there's the black marker and the white marker. And so one person is going to be the black, one person is going to be the white, or dimes and pennies, or whatever you're going to do. So you have different markers, and you're each trying to get 4 numbers in a row. So if I can use my die to make a math problem that equals 1, I can cover that up, and then on the next person gets to use their die to cover up 1 number. And so if they covered up the 2, that's blocking me from getting those 4 in a row. So then I'd have to see if I could get diagonal or go down, or make it somewhere else on the board. So there's an element of blocking each other or trying to get 4 in a row by using add, subtract, multiply, and divide to make 4 numbers in a row. So, and you get to color in 1 number per turn. If it's in your dry erase sleeve, then you can use 2 different dry erase marker colors. So that's it right there. So that's sort of more advanced version of Number Climber. Sometimes it goes on a really long time. It's really challenging, and sometimes it's very quick. Going back to kindergarten and on up games. So probably a very common familiar game with cards is War, which I call More. Who has more? I have a 1, you have a 5. You have more, so you get to keep both cards. And then we each flip over a card again. I have an 8, you have a 7, so the 8 wins, and I take both of the cards. To make it a little more challenging, you can do some variations. Double more, where you flip over 2 cards and add them together. So I have 5 plus 1, and which is 6, and you have 7 plus 8, which is 15, so you win. You can also do multiplication. So you got 8 times 8 is 64, and I got 5 times 1 is 5, so you win. You can even do this with fractions, where I have 1/5, and you have 8 over 8, that equals 1. Oh, I want to switch mine around. I have 5. 5 divided by 1 is 5, so my fraction's bigger than yours. So you can do fractions, multiplication, addition, or maybe subtraction. You could make the rule that it's subtraction, so you have to have your bigger number first, and practice subtraction with playing War, but flipping over 2 cards at a time. You can also do place value with War. So I have the 10s place and the 1s place. You flipped over 2 cards, and oh, is it going to be 51 or 15? Is it going to be 87 or 78? So you get to choose which one is the 10s place and which one is the 1s place. Okay, it's like that. You can even go from there and make it hundreds places. So they flip over 3 cards. It makes the war game go very quickly when you're flipping over 3 cards at a time and picking which one's your hundreds, 10s, and 1s. So kids can choose if they want to do it random, where your first one goes in the hundreds, your second one goes in the 10s, your third one goes in the 1s, or if they want to be allowed to look. And so I usually play this where the kid is allowed to arrange their cards, and I flip over mine randomly. So that way it gives them, they get to practice, they get to win more, and they have a motivation. They're playing against random chance and trying to see if they can do better by rearranging their cards to go, oh, you know, if this was 875, that would be a lot better than 578. You could even do thousands, dun dun dun. So that's very fun. Another game that I like to play, or here's another game that this comes from Mark Wall, I believe, and it's called Snake. And this game, the directions say to put a marker covering each of these little circles, and these circles have the numbers, and then in between, so you start on 0, and then it says plus 15 equals 15, but the plus 15 is covered up. And these are the places you land. So if I roll my dice and I got a 1, I would land here, and I go 0 to 15. What changed? Oh, they added 15. Yep, they added 15, so I get to keep that marker. So I got a point. And every time you make it all the way around in a circle, you get 2 more points. So you get to take two more markers from the extra pile every time you make it around the circle too. So all the answers are covered up, and this is a number trail where 0 plus 15 is 15, plus 100 is 115, minus 20 is 95, minus 50 is 45, plus 7 is 52. Another great way to do something very similar to this is with chalk outside, and making a number trail where there's lily pads the kids can jump to, and in between the lily pads, so it'll say 10, and then it'll say plus 10, and then the next lily pad is 20, and then minus 4, and they jump to 16. And so maybe they have to say the answer out loud when they jump onto the next lily pad. And maybe every fourth lily pad has the answer written on it, so they can check, were they able to track those numbers right, in sort of a number trail, where you take your number and you do an operation to it, and then another operation. And you can do that with multiplication and division too, to make it harder. Another chalk game I like to do is to make a grid of numbers. I can't show you, but to make a big grid of numbers and put all of the multiples, I'll have to draw it, all the multiples that you can count to on it, so no prime numbers, on a big grid outside with chalk, with squares about this big enough to jump onto, like 1 foot squares, and number each one with a not prime number, and then throw a beanbag or a pine cone or something into the number grid, and whatever number it lands on, you have to hop to, counting by something. So if it landed on 25, I could hop on 5, jump to 10, jump to 15, jump to 20, jump to 25, and pick up my my marker, and then it's the next person. So it's hopscotch, but with multiplication and sort of division. You're looking at the answer and saying, ooh, I got an 81. What could I count to 81 by? Nines. Okay, I will count by nines, and I'll have to hop, counting by nines. The other things to do to practice that multiplication, I have bean bags and bouncy balls. These come from something called Bal-a-vis-x, which is, anyway, this Bal-a-vis-x program, but they make these bouncy balls and these bean bags, and I love them for practicing counting by numbers, or just getting kids regulated and getting them moving a little, getting awake, alert. And so we do different tossing patterns. You can look up Bal-a-vis-x to learn more about that. But often we'll toss a beanbag back and forth. We will roll a die 12 and say, okay, we're counting by sevens. Okay, and I toss it to them 7, and they toss it back 14, and I toss it to them 21. They toss it back 28. We count all the way up to 70. So we do 10 tosses, counting by different numbers, and then roll the dice again. Okay, this time we're counting by 4s. Okay, and we might do a bouncy ball this time, and I'll bounce it to you 4, and you bounce it back 8, bounce it back 12, 16, so on and so forth, all the way up to 40, and then counting backwards. Extra challenge. We'll also sometimes do sort of yoga or sun salutations or stretches and exercises counting. So we might do jumping jacks counting by 2s, forward and back, or we might do leg swings counting by 5s, or we might balance on one leg counting by 10s, or whatever it is, counting by 3s while doing squats. And so that way is another good way to get movement in with your games. Back to my board games here. Sidetracked thinking about chalk and all the fun things we can do running around outside with math. Another day. This is called Nim, and if you turn it upside down, it says win. This game, you have 9 pennies you put in a circle, and you take turns taking, you can take either 1 penny, no, you can take 1 penny or 2 pennies, and your goal is to have the last penny. And so, and the pennies, if you take 2, they have to be next to each other. So there's 9 pennies in a circle, and you take 1 or 2. If you take 2, they have to be next to each other, and you want to take the last one. And so this could be a fun game to play with any age, and as they get older, they can be thinking about strategy and thinking backwards that, if there's 3 pennies on the board, it doesn't matter if I take 1 or 2, you'll win. If there's 4 pennies on the board, I want to take 1 so that you have 3 and you have no good choices, and then I win. So if there's 5, I should take 2 so that you end up with 3. If there's 6, what should I do? Well, I guess I'm going to be out of luck, because if you're thinking, you'll make me end up with 3 and then I'll lose. So they can explore the logic and the number patterns, working backwards like that with NIM, which is fun. Or they can just play it for younger children and have it be a wonderful mystery. This one is called the Jewel Thief, and it's very similar, and it's also out of this problem solving in mathematics book. And this one's very similar. You throw 15 markers into a pile, and then you can take 1, 2, or 3, and you want to have the last, you want to take the last one. So slightly different variations. And there are many, many variations on NIM with different patterns, different numbers. You can switch it and say you don't want the last one, and how does that change it? That whoever takes the last one loses, and so that makes it a different game. So these are just sort of nice games to be thinking about logic a little bit, and helping get kids engaged and focused, or being maybe a reward for after they do their math workbook, then we do a little game. This is called Tapatan. It's like, and that you can draw on a piece of paper and have a book of games that you made for yourself. So Tapatan, it's like tic-tac-toe, but you only get 3 markers each, and you take turns putting your markers down, 1, 2, 3. And then once you both have 3 markers on the board, then you get to slide them, but you can only slide them along those lines, and you're trying to get your 3 in a row. And so you have your lines showing all the different ways you can get 3 in a row. And if someone's on the spot, you can't slide there. You can only go 1 line segment. So it's just a different little challenge, and it's a fun variation. Another one is the spider game, great for Halloween, and you need to get 3 in a row, but this one you can't get 3 in a row on the edges because the edge is curved. So you have to have that middle spot. You take turns putting down pieces until you've put down all 3 of your pieces, and then you're sliding along these lines, 1 segment at a time, taking turns, trying to get 3 in a row. And you have to have the center and 2 opposite each other to get 3 in a row. So that's another fun game. Another one that I like as a sort of warm-up game is this one, which is it from Constance Cami? Probably. But I have all of these different shapes, and all of these shapes are made from exactly 5 squares. So you can see that this one is made from 5 squares. This one is 1, 2, 3, 4, 5, and they're each making a different shape. So one thing you can do is see how many different shapes you can come up with, of different ways of arranging your 5 squares, and they have to be fully touching on a side. So you can use some graph paper like this, and cut out pieces, and then I made some permanent ones in all these different shapes. And then I have this game board, which is 8 by 8, and you can take turns placing pieces on the game board, which is a graph paper 1-inch squares, and it's like Tetris, where you're trying to make all the pieces fit on the board. And this is a collaborative game. You're not playing against each other. You're just taking turns placing pieces and trying to get them all to fit. There's 2 more shapes that are made from exactly 5 squares, so it's more fun ones. Let's see, a couple more games here for you. There's also some commercial products available, like this is Math War, and on these cards they have a math problem on there, 3 plus 2, 5 minus 2, and these are all numbers within 10. So this is kindergarten level. There are also multiplication ones or division ones, or you can make your own set of cards, but it's a lot of work to practice those skills, and it's war, but you can also just flip over 2 cards and use that similarly. Something that I made with much effort was I made a set of clock cards. And so here's an example. I made a full deck of cards that are with clock faces and also with digital time to the quarter hours. So there's 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, all the way up to 12 o'clock. And there's all the 15s, all the 30s, all the 45s. And you can do memory matching with them. You can do go fish with them. You can play rummy with them. And I like to start with just the hours, and then just the half hours, and then the hours and half hours mixed together, and then the 15s, and then the 45s, and then with all of them mixed together. And so you can play any card game with these, but instead of suits, you have, so instead of clubs, you have the 15s, and instead of hearts, you have the 45s, and instead of diamonds, you have the 30s, and instead of whichever one I missed, spades, you have the hour, the o'clocks. And so you can play card games that way, which is kind of fun, and making them practice their time telling, or just matching up the digital time with the analog time with cards. So that took some work, but I really enjoyed them and used them with a lot of students. But it might not be worth it if you're just going to use them once. Something else that I've done, that I've made, is I made these, and these are, if you have a table saw, this is not hard. I took a piece of wood, we have lots of wood and cedar laying around, and I ran this through the table saw, moved the blade over, ran it through again and again and again, set very shallow. And this is really great for small hands to be able to put cards in, and it really helps them be able to play card games with this. So I made them a board to do card games with. Another something is cribbage. Cribbage is mental math adding to 31, and I introduce it slowly, adding a new rule each time we play. So first we're just, the last person to play that's less than 31 gets a point. And then I say, okay, if you get a pair, you get a point, and I slowly add a new rule each time we play. But it's great addition practice for kids. I'm looking around and seeing things. Any last things I wanted to talk about? This is out of the family math book, and it's more for middle school. And there's this set of clue cards. Miss Ruiz keeps starfish with 5 arms each, and octopi with 8 arms each. And then it has how many heads do they have, how many legs are there total, things like that. And then you use these 6 clues to try to figure out how many of the pets are starfish and how many of them are octopus. Or it has bicycles and tricycles, or cats and canaries, or cows and chickens, or whatever. And it's introduction to algebra. You can also do it with more elementary age children. You can do it with manipulatives or drawing and be able to solve these complicated problems. And so it's things like, I have, let's see, I have 16 feet in my house. I have cats and people. We have 16 feet in our house, and we have 6 heads. How many cats do we have, and how many people do we have in our family? And so once you do a problem like that together, then you can make up more for each other, which can be fun. Oh, here's another one I have. Is using fractions. So I have a number strip here, and then, I have a strip of paper here, and then I have all different, so I have 2 pieces that are each a half of that, and they say a half on them. I have thirds, and you can see it says a third on it. I have even a 16th, and so I took strips of these in different colors that are all the same length stripped. So I took the yellow strip and I cut it in thirds. And you can see that 3 of these yellow pieces equal the orange piece. And so on and so forth. Quarters, eighths, sixteenths. And then I made a die by getting a little blank cube and put fractions on it. So then you can roll the die and add and subtract fractions until you get it exactly right to fill your strip. Or you can do it with circles, cutting out a bunch of circles and having sixths of a circle and eighths and quarters, and you can practice finding equivalent sized pieces that way, like be the banker and trade in 2 sixteenths for a third and things like that. So these are pretty easy to make yourself. If you have some colored paper, you can make yourself a set of manipulatives for fractions, and that's generally 4th grade. It's getting really into fractions. We're going to have another time to, well, yep, we'll do reading and writing games separately. Thanks for joining me.